Welcome to episode 3, I guess, part 3, whatever. So I actually want to make a short revisit of the gamepad controller issue I had. Haven't solved it completely. And then I want to do some more background work on image processing. So as usual, here's my PowerPoint. So part 3, image processing, but actually I split it into part A and part B. Part A is the vgamepad library we looked at last time, where I wasn't sure if I'm using it right or not, and so on. So yeah, I made two methods. So one is using the DualShock 4 emulation, and the other one is using the 360 gamepad emulation. And so the first short button press is simply to make Windows think we switched on the controller. And then what I did is I have an infinite loop that makes it repeat pressing A or start in the case of Xbox, or cross. In fact, to be honest, we don't even really need the start part. Let me remove that. So it's similar. It will keep pressing A. Let me see. It will press it for half a second, then release it for 1 second. Press it for half a second, release it for 1 second. So, and what I did do. Let's get DuckStation running. Yeah, it says there's a PS4 controller, so at least this detected it. So I tell you what we're gonna do. We're gonna do this once more. I'm gonna close both emulators, get this program running, and let's, yeah. So yeah, here you can see this is going to the press start, which means this keeps entering and exiting the memory card manager, whereas Redux is doing nothing, unfortunately. To make, even though clearly it detects the PS4 controller. And yeah, if we stop this, this will stop. And I don't think this will work. Yeah, I don't know if you heard the Windows detection. So probably what we got to do is launch Redux again. Let's see. Well, both emulators. I mean, you can check already in Redux, it detects the controller. Yeah, this is the new controller, but it does nothing, and there you go, DuckStation is reacting. So yeah, bummer. So this method doesn't work as I hoped. I'll either try to find out the root cause or use another library or another method like using the Glue engine, because I really would like to stick to PSX Redux. Man, it doesn't roll off my tongue. Anyway, enough referencing to that. Stop this. Error. Let's clean this up. Clear output, clear output. So that's done. Go ahead and test it. Yeah, so what I want to do next is actually, I think a big chunk of this project's success depends on edge detection or boundary detection or environment detection. So it's my hypothesis that we need to figure out where the car is relative to the limits of the track. Yeah, we got these methods, we got hue lines, and I don't know if I got any good site open. Let me see. Nope. Anyway, so yeah, there's a good YouTube series by Shree Nayar, I hope I'm pronouncing that, from Columbia University. So I recommend watching his video. I'll put a link in the description. There's a number of series, a number of episodes on this sort of thing. So here he gives an example of Canny Edge detection. Totally worth watching his videos. They're very well explained, and yeah, of course, literature, academic publication is more reliable because it's normally reviewed and proofread. And on hue lines, this seems to be the book that's well referenced. So one thing I have a concern of is the resolution of PlayStation games. So, and I did actually cheat a bit, because I cheat in the sense for this video. I did do some work already with Redux, and it's very difficult to detect edges. And originally I thought this low res screen of the PlayStation and the low color palette will mean there will be less colors very smoothly blending into each other, and detecting the edges would be easy, and the computational effort to process such a small screen will be easy. But using this example, this screenshot, which is at the start line of a race at the high-speed ring, with in almost the exact same spot in game time. Ignore the lap time being different, because I used two emulators. So the left side is PSX Redux, and the right side is DuckStation. So you can see, and the DuckStation is running upscale. I can't remember at what resolution, but you can clearly see how, let's say, more smooth is the grandstand overhead compared to this very aliased line. And I think this is the first issue, aliasing, or aliasing, however you pronounce that. So here we have this fence. You can barely make out the edge of the fence. You can see there's some white dots here, but they disappear on the next chunk of the grill. In fact, of the fence, you cannot even tell actually it's chunked, except you can see some white vertical lines. Whereas on the DuckStation version, it's very clear. So I have this suspicion that ironically the low res is going to be a pain. And as you know, I want to try as much as possible develop methods that can run on real hardware. So as much as possible, I want to avoid concluding I need to upscale. To be honest, if I need to upscale in emulation, yeah, controller upscaling 2 factors against Redux. So let's see. Second issues I'm anticipating from my preliminary work is shadows. So look at this scene. The grayness of the track changes more significantly from no shadow to shadow than it does to the wall. Of course, further up, maybe the yellow is enough of a contrast, but within this region, we're going to be out of luck. And yeah, you'll see that in many corners we have similar issues. So that's one. Second is these algorithms, or some of them, I don't know much about them. So I want to first poke, trial and error, then go and read the literature, make sense of it. And yeah, that's the normal way I work. I get a rough, vague idea of what things do, poke around, then read the theory properly, and that's normally how it makes sense to me. Everyone has their own method of learning. So yeah, so what I did also, and I already started to draft up some code, I want to do this systematically. I don't want to run the game, take screenshots, you know. So what I did do is save a couple of images. Actually only prepared so far image 1, and what I did is call the left side image 1A, right side image 1B, 2A, 2B, and I'm going to load the still images, which are in PNG format, and do the processing on that. So yeah, so I already loaded the code. We're not actually going to use this. Let's call it unused reference code. So what I'm going to do is here. So I'm using the plot. I'm going to use the plot. So we're going to read the image. So 1A has examples. I think, yeah, there we go. We got 1A, 1A to 2B. Grayscale. In fact, let's do one more thing. So let's call this files and button. So visibility with Python is very quick to make lists that you can iterate So initially, let's work with one file. And then let's also tentatively, just to make sure it works. So let's see if we do that, will it print the gray? Okay. Oh yeah, because I have two plots. But anyway, so this base code works. So coming back to what I want to do. So I want to test how this Canny Edge detection works. So it has two parameters, at least two parameters, I think, that are always given, the threshold 1, threshold 2. So, think about this one. So I think we'll make it in 2 rows, maybe 2 rows. I don't know. Let's start with 1. And let's go 9 wide, 1 for the original image, and then 4 and 4. And we'll think about how it works, because I'm not too familiar with what's it called, subplots. So images. Okay, so we'll always, let's do that. So hey. So we'll always create a subplot, we'll always load the first image, and we'll always plot the first image, and then we always do a grayscale, then more index in range. Actually, is it index what we want? No, what we want is a new list. So let's see. Thresholds equals, I don't know, let's do 50, 100, 150, 200. And yeah, we'll do the same plus whatever it is. So plus doesn't make sense. Yeah. So I don't know what happens when threshold 2 is lower than threshold 1. This is the bummer of not reading text, so whatever. Let's do it like this. We'll see how it goes then. For each trash 1 in threshold written with it. Yeah, it is right. I don't know. For each trash, thresholds 1. For trash in trash 2, thresholds 2. And what we're going to do is create a processed image where trash 1 is trash 1 and trash 2 is trash 2. Yeah, and boom. And now what we want to do is, instead of saving it as processed image, we got images and we do append. So that way now we have a list of images. And instead of processed image, we go to give it gray. Now let's see. We could actually just plot it straight away. There's no reason actually to append it into an image, but yeah, let's do that. So I like this, but yeah, let's do like this. So instead, and we need parentheses, so it's, and yeah, then okay, not going to, yeah. Yeah, so the issue is I remove the parentheses. The way I define the axis, I'm going to have to loop each axis in the axis. You know what? Screw. It's a hack. Counting count equals 1. And count, and then count. That's 1. There we go. Let's run this, see if it works. What? Okay, 9 is out of bounds. So does that work? I guess not. I guess we lose the color. So what's happening? Let's see. Axis counts, count. 9 images. Okay. Silly. It's doing way more than 4 and 4, right? Because it's 4 times 4, which is, we need to split it instead. Let's think. Or what we could do, let's think. Because like this, we're generating, right, 16 images. Let's just check. Let's see if it works. So, yeah. But then ideally we visualize it differently. So that's what I think we're gonna do. So. And let's do this too. That way. So I think that will just plot the first one. X count doesn't exist. Excellent. And then pick a 1 X, and this one, let's do it 4 by 4. And let's see what happens. Okay, so now I have to know how you index. Yeah, it's actually what we wanted, right? So what's the issue? NumPy and here has no object image show. What did we do? What did we do? What did we do? So image show. X0 has an image show and it's just a subplot then. So let's see. Let's group it all together. So this is image processing. This is image buffer. What's bumming out? Wait a minute. Is that meant to be like that? Image show. Huh? Okay, let me just sanity check. Copy this. So it should plot the same image multiple times. No, so why doesn't an axis have an image show method? Interesting. What if we just did this? No. So I just have one more hypothesis. There's a way. Line toggle control / run it. Okay, I'm gonna pause here and come back with the solution. See you later. So actually not much time has passed. I think I figured out what's the issue. I think when we create this subplot, X becomes a 2D table, so to speak. So yeah, I think, what can we do? What can we do? So I think this needs to be a 2D vector. Let's just check my hypothesis. Yeah. So I think we're gonna go back to the old code. I tell you what. So images append like this, and then we'll take this out from there, and then let's see. How do we return the dimensions of a matrix? I know what, for now, let's just do it the old-fashioned way. For I range 0 to 3. Remember, we should try 0 to 3 over here before in Python. I think this, so and then j, and here's the tricky bit. We're going to get images I plus j. There we go. Let's see. Cool. So we got there. We just need to change this to a 4. Bingo. And we can decomment this. Excellent. This is exactly what I wanted. Now the only issue is how to make it visible, because it's in a notebook. So I'm pretty sure there's some, let's see, plot subplot size. Tick size. No clue. Okay, so let's see. Where's the subplot? Here we go. Let's see what happens. 15. Okay, now we're talking. Excellent. So, yeah, pretty interesting, huh? So obviously some of these, the way we define the thresholds don't make too much sense, I'm guessing. So I don't know, let's maybe step it in smaller steps, 100, 185, let's go that way. And then let's start at 150, 175, 100, 250, 150. Okay, so I don't know about you guys, but I see almost no difference between all the images. That's pretty interesting. Each one is making the difference. It's definitely noisier, and then immediately the next one is too noisy. Okay, without understanding what's going on, let's stick with this. I don't know, I feel like this is the time I would normally read the documentation, but whatever. So what I want to do is all of this multiple times for different images, but at this time let's just try image 1. So image 1 is the what? Okay, because now it's taking the high res, so now I remember what to do. Let's check the tunnel. The shadow. And there we go. So this is exactly what I was concerned about. You see, or what I was referring to. Here's the line of the shadow, and here it picks it up very strongly. When we go to the next method, or the next threshold settings, we remove the noise, but we lost any hope of seeing the barrier. But we see this really sharp line of the shadow. And yeah, look at this. In the previous image, we couldn't detect the differences in the different thresholds, but here, look at it, it's pretty clear. We've lost some detail here, we've lost more detail here. So yeah, definitely some differences. Now, what would be cool is we did this for writing files. For filing files, then all of this, let the images overwrite each other. Let's see. No, brilliant, brilliant. This is exactly what I wanted. Is it though? Whatever. So this method will require processing. Maybe what I should do is take the A and the B together. So put them side by side, because basically what I want to do is compare this image here to this image here. Yeah, so you know what? Let's hack it. So this was the DuckStation. And this is the Redux. Redux. No clue. English is my first language, but yeah, too many funky, probably Latin arrived words. So anyway, let's see. So you see, this is definitely heading in the direction of what we suspected, or I suspected. The high res of DuckStation makes it less noisy, but I also think the images, if we look at the original images, they are more blurred. Here we have, I don't know if it's dithering or something, but there's definitely smoothing out of the road texture, whereas here we have more chunky blocks. And the blocks on the ground are throwing us off. So, and then let's pick another pair. I don't know. Let's pick this one. So second row right image. I know this is so hacky. So what did I say? I already forgot. Second row full right. I think I said yep. Second row full right. Now, bearing in mind there are no pixel perfect identical positions in the track, because I had to, race to more or less to the same position, but close enough. Even the aspect ratio was slightly off. But yeah, so we're gonna need to find, I'm gonna have to figure out a way of how to distinguish these lines, which are non-continuous, and emphasize those as the track limits from these lines. Now, one idea is, well, there are many ideas. So they're on the side. So you could say, okay, if they're on the side, they're significant. But what if the AI drove stupidly too much to the left or stupidly too much to the right? So yeah, I think I'm gonna leave this video for here, and I think we'll be revisiting this in the future, obviously. Bye-bye. I'm back. So I continued playing around and want to share what I found. So, yeah, what have I done? So, I played with the aperture size of the Sobel operator. If you don't know what that is, Google it, read it. I'm not totally clued up on it. It has something to do with the matrix size in which it's looking for this threshold change, or for the clipping of the threshold. But anyway, non-academic answer there. Yeah, and so this is varying the thresholds, where I've set the bottom threshold as absolute values, the upper threshold as a factor of the lower, and kernels in this case is the aperture size. We see it produces a bunch of funky stuff. This one is, what's going on here? So why ain't you happy? Why ain't you happy? I don't know. Definitely something. Let's see what's wrong. Can't spot something wrong. So when in doubt, copy and paste. That shouldn't have been there. That's the run, sorry. Clearly, I should have not been here. Okay, so that's still working. Okay, this one works. So here, what are we changing? We're changing, yeah, Gaussian blur. Here I try equalization. So equalization is, did I save that? CV equal histogram equalization. I anyway think it's probably a computational intensive activity, but if say there's not a normalized, or I don't know if it's normalized, there's a narrow distribution of, is it brightness? I don't know. It kind of reflattens it so that there's some, all hues are visible, I guess, I'm not sure. But yeah, the result kind of looks like that-ish, in that it's made different, the different grays more pronounced. So then I experimented. Let's put this one. Let's put this it's threshold 2. Okay, it's doing something. So here I tried, what did I try? Equalization. Then I tried blurring first and then applying equalization. And I tried the blurring with different kernel sizes. And then I tried, okay, equalization and blur here, and here blur and then equalization. And I put all the results in. Also, I fixed some spelling mistakes. Even though looking at it, there's still some more, so I'm going to fix those as well. Replace in files. I think that's called trash. Call it trash. And replace all. Yep. So there you go. Yep. And let's push that. Clean Good, so let's look at the results. So this is where we left off previously, right? This was, spelling mistakes here too. So, I mean, trash, I don't know if that's even a word, but anyway. So what are we looking at here? These were some settings. I will scroll back to the video to check what they were because I didn't make a memo, so probably let's hide those slides. Yeah, so here we can see with the threshold at 50 and the upper, so 2 means 100, 5 means 250, probably it's a bit extreme, but anyway, and 10, so that would mean 500. So not much change at this scale. So if we zoom in, yeah, so on the right side, we're clearly losing barriers here, or clearly, subtly losing barriers. So later when I want to do hue lines, I think we'll not be able to capture them, detect them correctly because we have bigger gaps, maybe, not sure about that yet. And on the left side, we definitely, again, definitely, I keep saying definitely, we seem to lose the barrier here, which, as I suspected before, doesn't happen as quickly with DuckStation, right? So here we have random dots, here we have a more pronounced line. And here also on the right side, the barrier remains there for longer. So this is turning out to be, how to call it, a curse. I've chosen to try and stick to original hardware capability. Anyway, and when we go, this is, I mean, also pretty interesting, right? When we go to this setting, you can clearly see that DuckStation's high resolution original image allows us to detect more edges in the image, even with such a high threshold and a high upper threshold. Whereas the original image is completely, let's say completely, again, relatively undetectable. Here you can get an idea of where is maybe left and right on the track limit. Of course, we are biased by knowing what the track looks like, but here, anybody's guess. Unfortunately, it's only on that image. Here, when we're going into the corner, anyway, that's setting. Oops, that's setting. Here, there's the corner, the one where we have the shadow on the right. It's not visible. And yeah, so somehow I get the feeling we have to work with here. It's really going to be a nightmare how to get rid of the grill in this image. You gotta see. My image is to draw, one of my ideas is to draw hue lines and pick, I don't know, the closest hue line or the furthest hue line. Anyway, so this was playing around mainly with the lower and upper threshold, and clearly felt like upper threshold factor 2 and 5 were regions of interest. I don't know what to call that. And then here I tried with upper threshold factor 1, 2, and 3. Again, here 2 seems to be the better, no matter the resolution. I mean, to be honest, 1 is also pretty good. We kept this edge here and we keep this edge there. But the center of the track is pretty noisy. And one thing to look at is, could I use masks to cut out parts of the images and focus all effort in a limited section? I don't know. I have to look into masks. My concern is as we go to the left and to the right of the screen, where the ideal positioning of the mask might change. So, not sure. Then here I got tired of my previous method of copying and pasting. So there's something as the aperture size of the Sobel operator, if that's what it's called. Again, it's something to do with the size of the matrix size of the Canny Edge detection. Anyway, when you increase it, it looks insane and psychedelic. I might try playing it looking like this just to see what it's like. Also, one thing I'm starting to think of when processing this is I've always thought of doing it in frames, still images. I'm wondering if some form of time-dependent neural network, something that relies on what was the image before to, you're not going to have a lane jump to a smaller width and then jump back to a higher width. So if the processing is based on a neural network to track the track width, I don't know, maybe it will be slightly better. I don't know, too computationally expensive. Yeah, here we are. Oh yeah, here I applied Gaussian Blur. That's how you pronounce it. Yeah, almost every online tutorial of similar things I read said to do so. I don't know, it doesn't seem to solve the issues we had and only makes it worse. So as we increase the kernel size, so this Gauss K3 means 3 by 3, here's 5 by 5, here's 7 by 7. Yeah, the how to say, the detail is lost, and the issue we've had in the beginning, which is the shadow, it's still there. So here I tried another method, equalization. So to equalize the what I was mentioning earlier, the I guess the distribution of brightness. Interesting. I feel this is really interesting, and maybe this in combination with the mask has the most promise, because as we go left to right here, the right edge remained clear. What we actually are losing is the left edge, and the shadow is not as much as an issue. Now the issue is again just too much noisiness from detecting the pixels. And I wonder, thinking out loud now, if when we put the DuckStation image into this, will it be better? Because remember, earlier on it was that, where was it here? That, for example, at this setup, the DuckStation upscaled image was smoother or cleaner, I don't know. There was less of the texture noise being picked up. Incidentally, this is applying equalization first and then Gaussian blur. I tried the opposite. See, there's not much to it. And the equalization and Gaussian seems to be better. So let's very quickly test that one last combination. So this, we copy that, make a new code block, and let's say this is, let's make a more. So we're gonna do DuckStation upscaled image. So I wonder also, the aspect ratio of the DuckStation is slightly different from Redux. Maybe that's the main difference, I don't know. So anyway, we're gonna do DuckStation image plus, what was it? What did we say? Plus equalization, and that's British English, plus Gaussian blur. And so to do that, simply have to change these A's to B's. Let's go. Let's go. Pretty anticlimactic there. Pretty anticlimactic. I reckon it got worse. It got worse, so it didn't make a difference. Sorry if I'm making you dizzy there. So let's see. So this is what I've been doing now because I got fed up of. Yeah, so you can clearly see that there's clearly no significant difference. Bummer. I might have to experiment with more ratios or poke people for ideas. Yeah, let's just put it here. Upscale with equalization and Gaussian Blur. Man, have I been? Okay, so let's put it this. And maybe let's put that here. So we got the Redux, then upscaled, and then the solution. So yeah, we're now closer to having a clean enough of an image to process, or how to say, a clean enough processed image to start to detect edges on. Yeah, proving to be way more challenging than I expected to get over this wall. And to be honest, I believe this to be one of the biggest walls to overcome. So obviously if I could overcome this already, I'd be way ahead of schedule. From we're almost into the second month of 12 months for working on this. So yeah, not too bad. Could be better. So thank you. And for people who are watching this, especially if you know what you would do, or you can spot what stupid things I'm doing, please comment, help me. Subscribe, like, all that YouTubey stuff, which I always thought is cliche, but it does really encourage the creator to not feel insane like I'm talking to myself at my own monitor and webcam. So see you next time.